Okay, so let's think about the following functions. Y equals to f of x. That looks like this. And also y equals to g of x, whose graph looks like okay. Now our goal is to figure out the derivative's graph of the derivative. Okay, first identify where the slope is 0. Where is on which point of this graph is the slope 0? Here and there. I did not say the value equal to 0. We were talking about the slope equal to 0. What do I mean by the slope? I really mean the slope of the tangent line. So if you draw a tangent line here and you get a horizontal line, right? So what's the slope of a horizontal line? It's 0, right? So that's why I'm picking here and there. Okay. In other words, if you're looking for a slope 0 of a graph, you look for points where it's like a relative maximum or relative minimum. Sometimes it might be it might go like this. That's another case when you have a slope 0 momentarily, and if you continue to decrease. You should also look for these. Okay, now, so we know that when you draw the graph of the derivative of the derivative should be having zeros at these 2 points, what I marked here. Now, in between, should the graph be below the axis or above the axis? Between. What should I use? What's the argument? We think about the slopes in between, right? What kind of slope is this? Is this a positive slope or negative slope? Negative slope, because it's decreasing, right? So if the graph is decreasing, we know that it should be something like this. It has to be under, right? And before it should be over, and after it should be over. So that's like the rough graph of the derivative. For this one, let's just draw it over it. Draw the graph over it. Again, the same story. I point out the points where, figure out the points where you have the horizontal slope, because that's when the slope, when the derivative is equal to 0, because derivative is the slope of the tangent line. Now between here, is it decreasing or increasing? Decreasing, so it's under, right? Between these two, increasing or decreasing? Increasing, over, and decreasing after, right? Here it's is this decreasing or increasing? It's increasing. You always read the graph from left to right when you talk about increasing or decreasing. So it's increasing, so it's going like this.
So you only have to look at 2 things? You only have to look at 2 things, where the slope is 0 and the starting points of the graph?
So for simple graphs like this, that's all you need to know. Now, actually, let's go to question 16, because as in question 16, there's another problem similar to this, but this time you're on your own to graph it. Let's try this. 16. So in the first case, you have a graph which goes like up and down. Now this point here is given as 1, 3. And there's a point here that passes, oh, this is actually -1, -1. And it also passes through another point which is 3, -1. So what would be, if this is the graph of y equals to f of x, the question is, what is the graph of y equals to f prime of x? Now, if you have a straight line, these are supposed to be straight lines, does the slope change as you go? No. So what does that say for say about the derivative? The slope, since the slope is unchanging and the value of the derivative is the slope, the function's graph is a constant function. It doesn't change. It's always the same number. Okay? So that's something to remember. If you have a graph which is a straight line, then its derivative should look like a constant function graph. Okay? And we can actually figure out the slope of these 2 points just by doing rise over run, or change of y over change of x. So let's see, just put 2 numbers here and subtract. 3 minus negative 1 is 4, 1 minus negative 1 is 2. What is this? That's the change in y, that's the change in x. So the slope is change of y over change of x, which is 2. Right? So we know that if this is 2, until you hit the point 1, the graph of the derivative will always be 2. Now let's think about this one. What's the slope of connecting 1, 3, and 3, negative 1? So again, you subtract 3 minus negative 1 is 4, 1 minus 3 is negative 2. This is a change of x, that's a change of y, and the slope is change of y over change of x, which is negative 2. So we know that after 1, if this is negative 2, after 1, the slope is again constant at negative 2. Yes?
But how do you, why doesn't it start for the first, for the one where the slope is 2, positive 2? Why doesn't it start at negative 1? Why does it go all the way from, why is it from negative 1, comma negative 1 to 1, comma 3? How do you know it's all of it?
Oh, I just looked at the graph and it was passing through these 2 points. Now, if you chose some other point, it also passes through negative 2, comma negative 3. If you chose that one, negative 2, comma negative 3, and computed the slope between these 2, or these 2, you get the same answer too. I mean, if you have a straight line, it doesn't matter which 2 points you pick, as long as you pick 2 points from the line.
After 3, comma negative 1, going up, another slope.
Say that again?
Never mind, I'll ask you after class.
Okay. I mean, I'm given this graph, and I just put numbers to looking at the dots.
Yeah.
And then, since I see 2 lines, I know that the derivative will be constant here, and derivative will be constant here. So it should be constant before 1, and it should be constant after 1. Now here's actually another, yes?
Would you have closed or open circles?
Yeah, actually that's the question I was going to ask right now. So here's the important question. There's a jump discontinuity, right? So what do? Do you pick closed circle, open circle, what should I do? Why open?
Doesn't exist.
Because the derivative does not exist. Okay? Why is that? Is there a derivative at 1? What's the derivative at 1? Does not exist. It cannot be different. The function cannot be differentiated at 1 because the right derivative is negative 2, the left derivative is 2, and if the left and right derivatives do not match, what do you say? The derivative does not exist. Okay? It's not differentiable. Okay? Therefore, at 1, you have to put an open circle. Here's another one. The second graph I see in question 16 has an asymptote, a horizontal asymptote, which goes like this. Now you apply the same procedure as before. You just say, well, the derivative is 0 here, because it has a horizontal tangent, and it's increasing afterwards, decreasing before. Okay? So if you drew the graph of the derivative on the same page, the derivative should have 0 at the place where it has a horizontal tangent, and after that it's increasing, right? And before that it's decreasing, right? However, is that good?
Yeah, it's a straight line.
Huh?
It's a straight line.
No, it's not a straight line. It's a curved one which gets closer and closer to this horizontal
Or
line.
the river, the one that.
Oh. I mean, I mean, all we know is that it should be 0 here and it should be positive after and negative before. That's all we know, okay? Now, then, the natural question you should be asking is, how is it going on this side? Is it just going up like a straight line, or is it bending that way, or is it bending that way? What's happening, right? And to answer that question, think about what's happening to the slope as you go to the right. What's happening to the slope? It's getting closer and closer to what?
0.
0. It's getting flatter and flatter. It's like almost like a horizontal line if you go to the right. What's the slope of a horizontal line again? 0. So therefore, the value of the derivative should be going closer and closer to what?
0.
0. Okay. Same thing here. If you go this way, you see that the derivative gets closer and closer to 0, a horizontal line. So you have to come back here. So the graph of the derivative should be looking like that. Okay. And this is just a sketch. We don't even know where is this maximum or where this minimum is. We'll learn later something called an inflection point. And if you learn inflection point, you will actually see that the maximum should probably be somewhere here. So it should be more like that. But it doesn't matter. What's really important is you should be able to point out that it's 0 here, positive here, negative there, and it will get closer and closer to the x-axis as you go right or left.